number 17, chapter 5, talks about a person in a box that ends up getting thrown up into the air by a large rubber band. So we're just slightly past our normal physics fiction when it comes to problems from textbooks. So quick sketch, sometimes that's helpful. They tell us the mass of the person is 75 kilograms. They don't tell us G, but by now, hopefully, we know G on Earth, 9.8 newtons per kilogram. Again, the College Board would allow us to use 10 most of the time. Then they ask for the true weight of that person. Um, there's often some ambiguity about these different terms. True weight is a phrase that, from what they're saying, I then interpret that to mean, hey, let's find that gravitational force, Earth on the person. Um, they might just say on the AP exam, they could just say weight or gravitational force, something like that. So for their true weight, M times G, well, they tell us M, they tell us G, bada bing, bada boom, there you go. Then part B asks us to find the apparent weight while the person is in the air, while they're up here. Now, I don't know, the College Board generally hasn't used a phrase like apparent weight because different people might interpret that in different ways. They will usually ask something that's where there's no ambiguity, no uncertainty about what that specific term means. So instead of saying apparent weight, they might say um, they were on a scale both here and then there's a scale present here. They might ask, what's the scale reading while they're in the air? They might ask, what's the normal force that the floor exerts on that person? Something along those lines. One thing I'm assuming is that air friction is small enough to ignore. That's kind of a standard unless something in that problem implies that air friction is significant. There's nothing here that implies air friction is significant, but I'm just again going through and making sure that we have that acknowledged. Um, I did a brief little or quick little diagram. Again, there's the person, there's the floor. This is while they're in the air. There would be a normal force of the box on the person. There'd be a gravitational force, Earth on person. I'm choosing up to be positive and down to be negative since force are vector values. That's a useful thing to acknowledge and make sure we're aware of and using. And then I'm also stating here that the apparent weight is the normal force that the box exerts on the person. As we continue on, then if we're going to try to find that normal force, um, we really kind of have to find the only way we can really go is Newton's second law in the y direction. There's no equation where the normal force always equals this. Like total force always equals m times a. That's just always true. There's no similar relationship for normal force. For the normal force in this case, the only thing we can do is go Newton's second law in the y direction. So the sum of the forces on that person in the y direction is the positive force upward of the normal force box on person, the negative gravitational force of the earth on the person, and the sum of those should equal m times a. And that normal force is the thing that we're trying to solve for. So as we go on, normal force is mass times acceleration minus the gravitational force Earth on that person. Going through and expanding out that gravitational force to be m times g. I get this equals that minus that. And then while we're in free fall, if air resistance is small enough to ignore, then that means that this A should end up being the same thing. This is the actual acceleration of the person. And if air resistance is small enough, the acceleration of the person and the acceleration of the box should be the same. And this A should also be G. And that means that this force is then also directed downward. So we have this negative plus this, they're the exact same thing. So we should end up saying, hey, if the gravitational on them is about 750 newtons, well, the normal force, or pardon me, the total force would also be that, and the normal force and apparent weight would be 0. That person would feel weightless. Their apparent weight would be weightlessness and 0.